Okay, I wanted to explain this next lesson, and I'm not going to explain it very well because it's a little bit really over my head. The reason why is because it goes in with computer programming, and I don't know that much about computers. So nonetheless, we're going to work on this right quick. Some of this is going to be bonus. Other parts of it are going to be review. So if you'll look in your math book on page 31 at the bottom where it says 1.6, we're on binary and hexadecimal place value systems. I understand this a little bit. I don't understand it well enough to be a computer programmer, but that's okay. Okay, so it says this is the last lesson in this section. Now, this section is not anything you're going to be tested on or anything like that. This is just something extra to kind of get the brain juices flowing. Before we move on, we're going to take a look at the concept of place value. It is a very important concept. While I'm sure you're quite familiar with one current place value system, did you realize computers use place value systems based on value besides 10? Because you know ours is based on 10. Well, they use what's known as the binary place value system. Exploring this system along with the hexadecimal place value system is not only cool, but it can also help provide an even firmer grasp of the decimal place value system. So let's look on. Okay, turn the page. All right, so unwrapping the place value system. All right, so basically let's think of a container, like a big bowl of some sort, and we have a bunch of these. Okay, so in our decimal system, let's read at the top. The value that we choose is called the base. So what we use is 10. It's base 10. That's our decimal system because each container holds 10. 0 through 9, when we get to the 10th one, we have to move to the next container. Fill it up 0 through 9. When we get to the 10th one, we have to move to the next container. So each one holds 0 through 9, which is 10. And each container builds, this container is 10 more than this one, even though it's the same numbers. It's 0 through 9, it's just 10 more. And then this next one is 0 through 9, but it's yet 10 more than this one, and on and on and on. Okay, so our base, what goes in the container, is 10. So we're going to write 42. We're going to look at 42. This is at the top of page 32. You've got 42. That represents 4 sets of 10 and then two ones. So you see how that's written. You see those containers or those boxes. Each one of those has 0 through 9. Now the first one with the ones, that means 0 through 9, ones. The next box over is 0 through 9, but those are tens. So that would be 0 tens or 10, 20, 30, 40, 50, da, da, da. Okay, now let's move, that's our system. Let's move on to what's called the binary system. Computers use two place value system called the binary. Bi means 2. In a binary system, instead of allowing 10 values in each place, you only allow 2, 0 and 1. So in other words, its containers only hold 0 and 1. When you get to 2, you got to go to the next one. Same concept is what we use, but there's only 2 in each. So let's look at the number, in binary, the number 10 represents 1 set of 2 and 0 sets of 1 or 2. So here we have the two containers. The first one is the ones, and it only contains 0 and 1. The one that's 2s, which in ours it would be 10s, but since this is the binary system, it's 2s. So in that, it only holds 1, 0, and 1. All right, so if you have the number 1, 0, and you write it above those, well, that means that it's just one. The 10 represents one set of 2, and the 0 represents the 0 ones. So to make things clearer, take a look at the first 4 places or containers for both. So we're going to start with the ones. This is decimal base 10. This is ours. Ones, tens, hundreds, thousands. It goes 0 through 9 each one, but each one builds on 10. Okay, look at the top of the next page. Here you have the binary base 2. Okay, you have 1s, 2s, 4s, and 8s. Okay, because it's the same as, just like ours builds on 10, well, this builds on 2, and that's why it's ones, twos, fours, eights, and on and on. Okay, and each one holds only 0 and 1. Now, let's play with a couple of numbers. Here's an example. Okay, find the decimal value, that's our value of our number system, of the binary number 1010. Okay, so we're going to build our containers, and we're going to label them, and we're going to put the numbers where they go, 1010. Right below there tells what we do. So one set of 8, same as 8, 1 times 8, you get 8. 0 sets of 4 is 0, 1 set of 2 is 2, and 0 sets of 1 is 0. Add all those numbers up and you get 10. So in binary, the number 1010 is the same as the decimal number 10. All right, now we're going to find the decimal value of the binary number 1111. Same thing, you build your containers and you label them. You put your numbers over where they go, and then you do your figuring, and the 1111 in binary is the same as the decimal number 15. Because when you do all your calculations and figure, it's the same as 15. You good and confused? Good. All right, look at the next page, 34. At the top is a little gray box. I'm not going to even bother with that. It talks about computer circuits. That's way over my head. And then it goes into making computer talk more concise using hexadecimal numbers. So binary numbers translate well to electrical pulses when there's just 1 or 2. They tend to get big quickly. 8 is written 1000, making them difficult for us to read. So to help make numbers more readable, computer programs often use hexadecimal numbers, which is a place value system based on the number 16 to represent binary numbers. Because it has a larger base, meaning more can go into each container, 16 in fact. Okay, so in the decimal number 1200, 1200, in binary, look how it's written, 10010110000. In hexadecimal, it's written 4B0. Where do the letters come from, you say? Well, let's look at the base 16 hexadecimal system. Okay, there's 16 symbols, 0 through 9. A represents 10, B 11, C 12, and on and on and on. F going up to 15, which is the last one, because remember this is base 16. Okay, so that means each of the containers hold 0 through 15. So if you'll look at those, you have your 1s, 0 through F, your 16s, your 256s, and then your 4096s. Okay, it continues to go because each one is multiplied by 16. Just like in ours, each set is multiplied by 10. In binary, each one's multiplied by 2. Okay, so here is your base 16 hexadecimal system. Look at the top of page 35. Find the decimal value of the hexadecimal number 4B0. All right, so you're going to make your containers. You're going to label them. They're just 116s and 256s. Then you're going to put your letters or numbers up at the top. All right, so 4 sets of 256 gives you 1024. 11, because remember B is 11. 11 sets of 16 gives you 176. And then 0 sets of 1 gives you 0. So you add those up and you get 1200. So 4B0 in hexadecimal is the same as the decimal number 1200. Ta-da! All right, so place value systems can be based off any quantity. You can have any base, and other systems besides the decimal one are common in use today. Never seen it in my life, just letting you know. Each system is a tool to help us describe quantities, and each works best for different situations based on whatever field, career line you go into. If you are a housewife like me, you won't use that, or at least I don't think I have. All right, so the assignment today is worksheet 1-6, which is 4 pages long. All right, so I'm going to let you choose whether you do the binary and the hexadecimal that we just talked about. All right, so on the front page of worksheet 1-6, number 1, all goes over the binary. You can go back and look in your book. If you want to do it and you do it correctly, we'll use this for bonus points. Okay, on the next page, it goes over the hexadecimal, and it adds a little bit to it. It starts talking about colors that computer programmers use, the RGB color system, red, green, blue. it took me a few minutes to study it, but I studied this and I read through it again and again and again and looked at the numbers. Did not cheat and look in the teacher book. I did study it and I did finally understand it. So because this is not anything that you have to be tested over or anything like that, this is something extra, I'm going to let you choose. If you choose not even to look at it, that's fine. You don't have to. But if you choose to go through these pages and you get them correct, then we'll give you bonus points. Okay. Now, the assignment that's not optional starts on page 35 of worksheet 1.6. Number 3, comparing numbers, do all that. Do all of number 4. On the next page, all of number 5 and all of number 6. Number 7A and 7B are also optional because they're going back and talking about what we just did. Those are bonus questions as well. So the ones that are not optional, 3, 4, 5, and 6. You have to finish those, and I'm going to grade those. Not sure yet what that's going to be worth, but I'll put that on Google Classroom so you'll know what that's worth. Okay? If you need any help, let me know, but I think most of all, it's mostly review. And that's all for today.